Hey guys, welcome back. So today we'll be discussing about the Hadoop job process. In the earlier session, we saw the Hadoop architecture. We saw how the different components like HDFS and MapReduce are managed by the different services or daemons like your name node, data node, secondary name node, job tracker, and task tracker. Okay, so we saw how these each and every component are shaped up together. And what we saw is that your Hadoop cluster, apart from the Hadoop client, visualizes to something like this. So you have an operating system installed on each and every server which occupies the 30% storage space. Then you have your jar files and XML files into your Hadoop installation. Apart from that, what you get is the two sections, one is HDFS and one is MapReduce. The HDFS section is handled by the services, namely name node, data node, and secondary name node. And the MapReduce is handled by the daemons, namely job tracker and task tracker. Talking about these daemons, your name node and job tracker are the masters, and data node and task tracker are the slaves. We'll not talk about secondary name node at this point of time. Okay, so but this Hadoop is a master slave architecture. So we have all the services present in each of the servers, but we have not yet configured them, or we have not started the master and slave stuff in there so far. So now what we'll do is we'll start the name node and job tracker in the server which we want to configure as the master, and we'll start the data node and task tracker in all the servers which we want to configure as the slaves. So after doing the configuration, what we have is something like this. You have name node and job tracker services in the master server and data node and task tracker services in the slave servers. For the demonstration purpose of the Hadoop job process, I have taken 3 slave servers in here. Now what happens is after the configuration and everything is done, now we are ready to work on the actual data. So my Hadoop client has a text file called as hello.txt whose size is 180 MB. Now my Hadoop client has to store this file inside my Hadoop cluster. So he'll tell my name node that, okay, dude, you're the master of storage. So please save my hello.txt file inside your cluster. So the name node will go into the jar files and the XML files and inquire that, okay, somebody is telling me to store a hello.txt file, which is a text file. So what should I do? So the jar files and the XML files will intimate the name node that what you need to do is request the Hadoop client to split the files into chunks of 64 MB each. So on the suggestion from the name node, the Hadoop client will distribute this hello.txt into 3 blocks. One is even, whose capacity who is 64 byte in size, MB in size. The second block B1, which is again 64 MB in size, and the third block C1, which is 52 MB in size, because that is what is remaining after 64 and 64 MB splits. So make a note here that suppose if your file is only 10 MB, then you'll have only one block whose size would be 10 MB. Next up, the name node tells the client that Hadoop is a reliable framework. So what we want to do is we want to replicate these files now. And the default replication that Hadoop follows is 3. So please go ahead and replicate these files two more times. Replicate each of the chunk 2 more times. So the Hadoop client will go ahead and replicate A1 as A2 A3, B1 as B2 B3, and C1 as C2 C3. So now the file is split into blocks of 64 MB. The blocks are replicated based on the replication factor, which is by default 3. And now it is time for the name node to actually go there and store these blocks in the cluster. So now what the name node will do is, based on the number of data nodes he has, he'll create a mapping. So he'll say, I'll store block A1, A2, and A3 in data node 1's HDFS, B1, B2, and B3 in data nodes 2's storage, C1, C2, and C3 in data nodes 3 storage, which is again data node 3's HDFS. But if we have a careful look at this, then what if suppose the server on which data node 1 is running fails or goes down, then we lose all the copies of the block A. So there is no point of doing the replication then. So this kind of a mapping is actually wrong. So what the name node does is the name node actually creates this mapping by a random distribution of each block by just taking one consideration into mind, that no two copies of the same block are stored on the same server. So based on this consideration, he will create a mapping which will look something like this. So there would be blocks A1, B2 and C3 in data node 1's HDFS, B1, C2 and A3 in data node 2's HDFS, and C1, A2 and B3 in data node 3's HDFS. Now based on this mapping, the name node will go ahead and distribute the blocks. So we'll store block A1, B2 and C3 in data node 1's HDFS, A3, B1 and C2 in data nodes 2's HDFS, and A2, B3 and C1 in the HDFS managed by your data node 3. Now this completes your file storage, and now it is the time to work on your program. So next step in the Hadoop job process, what we have is you get a program. Now talking about this program, all the Hadoop code is in Java. Hadoop understands only Java language and the Java programs. So all the programs are bundled in a jar file. Talking about these jar files, the jar file has three class files: a map class, a reduce class, and a main class. So the map class has a map function, the reduce class has a reduce function, and the main class serves as the execution starting point, and it defines the map and the reduce classes. So coming back to our Hadoop job process, as soon as the program.jar file tries to enter the Hadoop cluster, the job tracker, who is the master of processing, welcomes the file. The next step what the job tracker does is, the job tracker distributes this program.jar to all the task trackers as a whole. This program.jar file is not split or not done any processing with. It is given as it is as a complete chunk to the task trackers 1, 2 and 3. Okay. Next up, all the task trackers are given a message. Suppose task tracker 1 is given a message that run the program on block A1. Task tracker 2 is given a message that run the program on block B1, and task tracker 3 is given a message that run the program on block C1. Next up, the job tracker intimates all the task trackers to start the map phase. Upon this intimation, what the task trackers do is, the task tracker 1 executes the map function on block A1 and gets an output. We'll call it as mapper1 output. Similarly, task tracker 2 will execute the map function on the block B1, which is available locally in the HDFS, which is managed by its data node, which is data node 2. So we'll execute this map function on the block B1 and produce something we'll call as mapper2's output. Then similarly, task tracker 3 will execute the map function on block C1 and produce an output called as mapper3 output. After each and every task tracker is done with the map function execution, they'll intimate the job tracker saying that, okay, we are done with the map phase. Now what next? Upon this, the job tracker will tell the task trackers that, okay, now start the reduce phase. So now what happens in the reduce phase? As soon as the job tracker gives this message, what he also does is, from all the available task trackers that executed the map function, he randomly selects one task tracker as the reducer. Now suppose the task tracker 2 is selected as the reducer. So now what the task tracker 2 will do is, it will collect the output from all the mappers. Now let's call it as a mappers combined output. Now what task tracker 2 is doing is, it is collecting the mapper 1 output from task tracker 1, collecting the mapper 3 output from task tracker 3, and he already has his own mapper 2 output. He will combine everything together and prepare something we'll call as mapper combined output. Now the next step he'll do is, he'll execute a reduce function on the mapper combined output and then give us the final output. Once the final output is prepared, once the execution of the reduce function is done, the task tracker 2 will intimate the job tracker that, okay, I'm done with the program execution. And then the job tracker will intimate the Hadoop client that, okay, all my task trackers and everything, my Hadoop cluster has, done with the program execution, and now we can call it up. And this is how your Hadoop job process looks like. Thanks a lot for watching this video. Stay tuned so that in the next session we'll have a look at what exactly happens in each of these phases, and then we'll see what are the input and output in each of these phases. Thank you. Thanks a lot.